now that we've seen two different ways that we could go about solving quadratic equations, now the question is, when should we use each method? Like, when would it be better to use the factoring method? When would it be better to use square root method? Okay, factoring should be used when you notice that you have a trinomial. So I'm referring to when you have the equation in standard form, when everything's to one side and it's equal to 0. If you notice that you have all three terms, if you have the x squared and then the x and then that normal number without an x at the end, that's when you'd want to use factoring. Another situation where you'd want to use factoring is if you have a binomial, but you notice that both terms have a variable in them. So if you say, okay, both of these terms have an x, and they would obviously have an x in common, and you would be able to factor out a GCF. Square root method is a little bit easier to use when you have a binomial where one of the terms has the x squared and the other term does not have a variable at all. Okay, so what I want you to do is take a moment here, go ahead and pause the video, and look at these 6 examples down at the bottom. I don't want you to actually solve them. All I want you to do is decide which method you should use. Should you use factoring or should you use square roots, and why? So make that decision and give a little explanation of why you've made the decision you've made for those 6. So go ahead and pause the video, unpause it when you are done. All right, for number 1, this one is a trinomial. You should use factoring. So if you look at your pieces, you got one piece there, the v squared, you got a second piece in the middle, you got your third piece. So this would be a trinomial. You should use factoring for this one. Okay, you can't actually use square roots. You would have to do factoring. For number 2, this would also be a case where you'd want to use factoring. In this case, it's a little different than number 1. You have a binomial, so there's only 2 pieces here, but both of those pieces have a variable. In this case, both pieces have a p, so you can pull out a GCF or factor out a GCF and break it down into factors. For number 3, the easiest way I think to solve number 3 would be square roots. Okay, this is a binomial. You only have 2 pieces. One of the pieces doesn't have a variable. This one has the x squared, but the other one doesn't have a variable. You could actually technically do this one by factoring, by using our difference of squares, which was kind of that special case factoring. But honestly, personally, I think square roots would be the easiest way to go about this one. For number 4, this one is definitely a square roots. All right, you have a binomial. That second term does not have an x, does not have a variable with it, so you would have to use your square root. So you would move the 6 over, divide by 3, and then get rid of that x squared with your square root symbol. All right. Number 5 is not quite in standard form first. So if we think about maybe moving this over, moving that 2p to the other side so that we have our equals 0. So again, before you decide what method you want to use, always make sure you set things up into standard form to really see what you're working with. Because this, if you didn't pay attention, this looks like it's a binomial, but in reality, when you move that 2p over, it's actually a trinomial with 3 pieces, which means this one should be factored. Okay, so again, before you make that decision, double check. Everything should always be in standard form before you start working with anything, or before you even start making decisions of how you're going to work with it. All right, and then the last one, this is going to be square roots. Okay, notice you have your equals 0 there, so it's already in standard form. This term does not have a variable, so we only have the a squared here. That second term has no variable, so you would want to move that 102 over, divide by 10, and then start using your square root to start getting rid of that exponent. Okay, so just kind of seeing the difference between the different cases and kind of thinking about, all right, I have these 2 methods, and really making sure we know when would it be more appropriate to factor versus when would it be more appropriate or easier to use square roots.